Welcome back, llamas. This is block 4 of topic 9. Probability on page 279. And yesterday we did some experiments. Today we're going to look at some experiments and talk about a couple new vocabulary words. So here we go. First thing is, imagine I have a jar and I have 12 marbles in that container. There's 3 different color marbles in the jar. If you win the correct color I pick, then you win. So on A, first, here's a picture of my jar. There are green marbles, blue, and yellow. 12 marbles in there. I'm using this jar to recreate another jar, large one, that has 300 marbles in it. But I want it to somewhat mimic this small jar. So what I want you to do on A is to write G for green, B for blue, and Y for yellow. And I want you to predict in my container of 300 marbles how many of each color should be yellow, green, blue. Okay, so you're predicting based on this smaller jar. So I'm going to give you about 45 seconds to write 3 numbers down. Those 3 numbers should add up to 300. So 45 seconds, write 3 numbers down for each color, random numbers. You could use some brain cells if you have some, but other than that, I guess random numbers. I had some people in earlier hours have 100 for each of them. Well, using a few of my brain cells, I can see that there's more green marbles than any other. So I probably wouldn't write 100 for each. 30 more seconds. Writing 3 numbers. Your neighbor is about to look at it, so you need them down. 15 seconds.
Why don't you? Oh, there's 3 colors.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, neighbors, look at what your people wrote so they don't change it through the lesson. And we'll see who had it correct. We don't want any cheaters in here.
He's doing that.
We should be done though. We can't write anything after now. All right. Zip it. Zip it. I've asked you to zip it. This would be the 4th time now I've asked you to hush. That seems like a problem. All right, so you have some predictions down. Hopefully you use some math or logic to come up with your numbers. I'm going to use this spot just to record how many there were of each in my small jar. How many green were there? 6. And blue there was 4. And then 2. Okay, on B it says, what is the theoretical probability of choosing each color? So the probability of choosing a green, how many green are there?
6.
6 out of how many total marbles?
12.
12, so the probability of that is
1/2.
1/2. I appreciate those that's writing this down like they're supposed to. Then I'm looking at the probability of blue. How many total blue do I have? 4. Out of how many total blue? That simplifies to 1/3. Then looking at the probability of yellow. How many yellow? 2 total, or is 12, and that reduces to 1/6. So what color is most likely supposed to get picked? Green. Least likely to get picked would be yellow. That's what our theoretical probability says. So that kind of answers question C. What color of marble is most likely to be drawn from a container? Green. And why? I could say it has the highest theoretical probability, or I could say half the jar is green. I like the highest theoretical probability though. Forgot some words there, because it has the highest theoretical probability. Okay, D basically asks, what do you think is more, what's the word I'm looking for? What, between experimental and theoretical probability, who has the better likelihood of it actually happening that way?
Wait.
Experimental or theoretical? Who has the more reliable outcome?
Experimental. Because theoretical.
Experimental, I could just so happen to get blue every time. If I do that same experiment the next time, and I get all green, is my data equal there?
No.
The most reliable data is theoretical, because it has math behind it to prove why it could happen. So here we're going to say I mess this word up the whole time. Is more accurate.
So theoretical is like the opposite of just making you guess.
A guess is neither of them.
Estimate.
Experiment, you have to conduct something. Theoretical is the data behind it. Yeah. I misspelled accurate, but there's a U there. I wasn't accurate in my spelling of accurate. All right. Now to see if your predictions on C was correct. So, let's look at green first. And green had 6 out of the 12, right? I want to look at something that has a total of 300. Why did I put 300 at the bottom? That's the total. And over here, 12 is also the total, and it's located on the bottom. So I'm looking for this numerator. So I have to ask myself, 12 times what gives me 300? And it is 25. So 6 times 25 gives me
150.
So raise your hand if for green you had 150 written on your A section.
Oh, no, didn't.
Alright, Brady, stop.
Okay. We got some fibbers in there.
Brady's fibbing.
Alright. Let's look. Hands down.
I got one.
Let's look at blue. Blue had 4 out of 12. And we're looking for a container of 300. Same thing, we're multiplying times 25. So how many blues should there be?
100.
Oh, yes.
50. Please just be 100.
It is 100.
Dude, I drew 40.
Raise your hand if you've got both numbers correct so far. Both. Okay. All right, let's look at yellow. Well, if you got both numbers right and your numbers indeed add up to 300, then you should get the same.
I got this one.
And that's times 25, so 2 times 25 is 50. Raise your hand if you got all 3 numbers correct.
How did I get?
Brady, not get one right.
Anybody else?
Very impressive. Hey,
People lazy.
picking up a lot of extra noises and not mine. All right. So, I'm not going to make you write down these 2 vocabulary words, but I want to talk about them and how they kind of seem like common sense. You have such thing as a certain event, and then you have such thing as an impossible event. So imagine that I have a rigged coin. And both sides say heads. And I flip that coin and I call heads. Is that a certain event or an impossible event? It's certain that it's going to land on heads. Okay? If I had a 2-sided head coin again and I flip it and I call tails, certain or impossible? Impossible. Okay? Imagine I have a 6-sided dice. Normal dice. And I roll it and I call any number.
That's certain.
I say a number is going to be landed. Is that certain or impossible? Certain. I said any number is going to be landed on.
Oh, that is a fact.
That is certain. If I roll that same die and I call an 8,
That's just
Impossible.
that would be impossible because there's not a side that says 8 on a 6-sided die. Okay. If oh, this was a good one. We had a national championship game that was the Tigers versus the Tigers. What is the possibility that the Bears were going to win? Impossible. What was the possibility that the Tigers were going to win? It was certain. Okay? So that is the definition of certain and uncertain and impossible. What I do want you to write on the bottom of 280, because you don't need that much room on the bottom of 280, there's this scale that we like to use. It's really a number line. And 0, if I get the probability of 0, I have an impossible event occurring. So if my probability ever came out to 0, it's impossible. If it came out to 1, which is 100%, what is that?
Certain.
Certain. It's certain to happen. Well, if it came out to 1/2, any ideas of what I could call 1/2?
Certain and
Probable.
It is called equally likely. It's equally likely to happen. It's got a 50-50 chance. If it landed somewhere around the 1/4 range,
Not likely.
it is
Not likely.
considered unlikely to happen. And if it lands somewhere about around the 3/4 range, it is most likely to happen. So if my fraction that I calculate for probability, I can use this scale and I can see what word I could use to describe that event for happening. So let's go back to A here. The probability of having a green was 1/2. What am I going to call that? Equally likely to happen. 1/3.
Unlikely.
What is that close to here?
Unlikely.
Unlikely to happen. And then my last one, what was it? 1/6?
Yeah, unlikely.
So nothing can be impossible unless it's 0. So it's still going to be considered what? Unlikely. Only 0 can be impossible and only 1 can be certain because it's 100%. Is 99% certain? No. So you see commercials on TV that say this is 99% sure it will help you or something?
Clean it, what's it called?
Germex.
Germex.
Germex kills 99.9% of germs.
Wait,
So-
that's fake?
Huh?
No.
Fake?
So if you have
They just don't do it.
It is most likely to kill germs,
No.
but they cannot be certain it is killing all germs.
The reason they do like 99 is because like if they do 100 and it doesn't kill germs, then they can get like sued and stuff.
Exactly.
Why would you say equally likely for yellow and not the yellow and not most likely?
What was yellow? 1/3?
Yeah, no,
1/3 is smaller than a half. So
not yellow, I'm sorry, green.
green is equally likely
But why wouldn't it be most likely?
because 1/2 is equally likely. Most likely is where it's above 1/2, but smaller than that. All right. Moving on to number 2, we have a definition of a complementary event. A complementary event, the best way I can put it in words for us to understand, and I done forgot how I like to word it, is all other possible outcomes. It's a list of all other possible outcomes is a complementary event. So if I had a heads and tails coins, and I'm looking at the head side, its complementary event, what else could it land on?
Tails.
Tails. So its complementary is tails. If I had a dice and I'm looking at the 5 side, what is complementary to the 5 side?
Every other one.
1, 2, 3, 4, and 6. It's complementary. It's all the other possibilities. If we need to write an example down so that we know, so let's write this one down. We're going to say what is complementary. to rolling an even number on a die. So rolling an even number on a die, what is complementary to that?
What's a die?
Die is just one dice. Dice is plural. Die is singular. ELN. So, what is complementary to landing on an even number?
Landing on an uneven number.
An odd number is what we call those numbers.
You spell it like that?
Yeah.
Oh, that's messed up.
I have a dot.
They couldn't have put.
You don't have any of this written either.
She is really learning this.
I gotta go to the doctor.
That sounds like
Because I was throwing the baseball last year and my arm popped and I didn't think it was so I went
Everybody needs to be experienced.
Why doesn't this go up?
I know I'm playing. They're listening to you. All right. Moving on to 3. We have some different experiments that I could do here, but we're wanting to find the theoretical probability. Leave it alone. So this first one, I'm looking for the probability of 5. It says there's going to be 2 out of how many? 5 spaces. Then I'm looking at the probability of not 5. How many are not 5? 3 out of a total of 5. The probability of an 8 on that die. 0. Where does 0 fall on that scale? Impossible. So I could say impossible. What about 2/5? What could,
unlikely.
it's less than a half, so it's unlikely. 3/5?
Likely. No,
Most likely. 0 would be impossible. The probability of selecting an A marble. 5 out of 7. Probability of not green. 5 out of 7 are not green. And then the probability of tails. 1 out of 2 sides. How likely is it for me to land on tails? Equally likely. How likely is it for me to not get a green? Most likely. And then probability of an A? Most likely. Okay. Number 4. Imagine I have another jar of marbles. 3 of them are green, 5 of them are blue. How many total marbles are in the container? 8 marbles. We want to add some yellow marbles in. And we want the probability of yellow to be 1/3 or 33%. Well, so picture the jar with 8 marbles in it. I'm grabbing a yellow one and putting it in the jar. How many marbles is, if I add 1 to it, is in the jar?
9.
So that means all your probabilities have to be recalculated with a total of 9 marbles. If I add 2 yellow marbles to it, I'm at a total of 10. They all have to be recalculated to 10. Okay, so here is an image to show you what I'm talking about. So I have a jar. The probability of blue and green and yellow is shown. Right now, what is the chances of me picking a yellow?
0%.
Impossible. Okay. The others are least likely and most likely. Okay. So if I add one yellow marble, we're at a total of 9. Do you think that is gonna equivalent to 1/3 or 33%?
No.
Okay, so how many think I need to add 1 marble? 2 marbles? 3 marbles? 4 marbles?
Wait, are you counting the one that you already did?
I'm saying
No.
5.
Oh,
4 total yellow. 5 marbles? 6 or more? Okay, we're gonna see if y'all change your answer. I'm going to put 1 marble in. I now have a total of 9. Recalculate. I'm at 11%, 1/9. I'm looking for 1/3. Who says 2 marbles is gonna do it? Have faith in your own answers. 3 marbles is gonna do it. 4 marbles is gonna do it.
All the dumb people.
I like how you just like how
Yeah, he's about to get played.
Oh,
You know-
shoot.
You know why? Let's use our brain for a second. What's my total right here?
9.
9. If I put 2 yellow marbles in, what's my total?
11.
10. That means
What?
if I put a total of 2 yellow marbles in, that's 2 out of a total of 10 marbles. What does that reduce to?
1/5.
1/5. If I put a total of 3 marbles in, that's 3 out of 11. Does that reduce to 1/3?
No, it stays at 311.
If I put 4 marbles in, 4 marbles in, I'm at a total of how many marbles? 12. Does 4 12 reduce to 1/3? So all the goobers weren't just raising their hand, they had some brain cells.
I knew. I didn't want to doubt him.
Excuse me. I'm recalculating. I'm just at 20% with 2 marbles. Recalculating. I'm not there yet. And 4 marbles. We are there.
Well, I'm the dumb one now. Well, we were all
You weren't alone, yes.
I was alone.
You went up down with the sinking ship with fellow mates.
And got it all.
Okay?
Which ones did you raise your hand for?
5.
Thank you.
Alright, so here we can say 4/12 because that gives us 33.3% for number 4. Is our logic there? So that had us really using some brain cells to think about recalculating. So maybe those GPSs that always say recalculating, they're always having to, oh my gosh, we're not that far away, or we're further away.
You wasn't in your head.
It kinda hurt.
Or they're rerouting.
Alright, number 5, I would like to do with you, if you don't mind. It's kind of fun. Number 5 says, Sue is currently a 6th grade student at Boston Middle School. She must now register for classes for her 7th grade year. All 7th grade students are required to take a math class. A computer will randomly assign a teacher to each student. Use the table to answer the following questions. Express each probability as a ratio. What does a ratio look like? What kind of number?
And then there you got 2 dots.
Does it look like a percent?
No.
What does it look like?
Why is it like a number that holds? Has everything matters?
It can be, but it looks like a fraction. So if it says, give me a ratio, it basically just wants you to give it a fraction.
Why is
Why do you keep talking right here?
everything math and science? It's required to have math class.
Stay there.
No, but there's no.
So, well, it's a wonder that I read this paragraph and it says she's required to take a math. So let's look at the probabilities of what math teacher she's going to have. Okay, so we just want to look at the teachers that teach math.
No, I don't.
But some of them teach us several things. Okay. So, it said, this is actually how y'all's schedules are made. We take each individual student and we say, this kid needs to be in advanced math, this kid needs to have an ELA, a science, a PE, and then we go to the next kid. Well, this kid's not good, scored low on the LEAP, so we are in regular math, but also needs to take a math lab and ELA and whatever, so we do that for every student. Then they hit a button once they programmed every student in, and it disperses them out to the teachers. And each teacher has in the program what they teach and what hours they teach it. So when we hit that button, it spreads the kids out, and you have your schedules made.
That's cool.
So this is really how you end up getting a schedule. So it says, what is the probability that Sue will have a male math teacher? So the probability, and it says they want it expressed as a ratio, a male math teacher.
2, 6.
How many teachers are male? 3.
2.
3.
2.
2. Out of how many total teachers?
6.
That reduces to
1/3.
1/3. So is she equally likely, most likely, impossible?
Unlikely.
She's unlikely to get a male math teacher. What is the probability that Sue will have a math teacher who teaches both math and science? So we're looking at the probability of math and science. How many teachers teach math and science? 3 out of a total of 6. So the probability is equally likely to happen. What is the probability that Sue will have a math teacher who only teaches math? So only math. Who teach? How many teach only math? 1 out of 6. What is the probability that Sue will have her favorite teacher, Mr. Garza, as her math teacher?
Impossible.
So we're looking for the probability of Mr. Garza. And the chances of that happening are 0 out of 6, which would be impossible. What is the probability that Sue will have a math teacher in 7th grade? Well, how many? It did say up there they're required to take math. And 6 out of the 6 teachers, so that is 1, which is certain she will be taking math. How certain are you? Ooh. What's your probability of taking Algebra 1 next year?
Certain.
Impossible.
100%.
Most likely.
99.99.
I think for everyone at this point, it's most likely. Because the only way you can get into algebra is scoring a mastery or advanced on your LEAP. And whether I say that you're mature enough to handle the Algebra 1 or not.
I'm mature.
Why are you looking at me?
I didn't even look at you. Pretty sure I was the one that said, let Brady come in to advanced math.
Because she didn't want you to feel bad that Bailey did.
Okay. I'm gonna set up the next two, then you're gonna finish them. 6 says, sketch a spinner with 5 equally likely outcomes. Label the sections of the spinner with numbers 1 through 5. So a spinner, I need a circle, flattened out V, and a smaller V, and then, that's good. It's about equally spaced. Says to number it 1 through 5. Then it says if you were to spin the spinner once, what would be the possible outcomes? So that's one question I have to answer. Express the theoretical probability of each outcome as a ratio and a percent. Okay. So possible outcomes are listed in face brackets. They're called face brackets because it's a forehead, pointy nose, and a chin. What are the possible outcomes I could land on? 1, 2, 3, 4, 5. Those are the possible outcomes. Then it says find the theoretical probability of each as a ratio and a percent. Well, each of them, I gotta find as a fraction and then convert it to a percent. I'll leave that up to you. I'm gonna go down to number 7 and set number 7 up. Says the faces of a 6-sided number cube are labeled with even numbers 2, 4, 6, 8, 10, 12. Says list the outcomes, so just like we did above. Express the theoretical probability of each, just like we did above. Does it say how they want it, the theoretical probability? No. So I could leave it as just a ratio or just a percent or both, whatever you want it. So this one's done a lot like the top one.
So all we have to do is the same thing.
Pretty much. And you have enough time to probably knock that out right now. So thanks for listening. Have a great day following Llama followers. And like, subscribe, hit the notification bell, and
Peace out, baby.
we'll have merch coming soon.
Yeah, for